Good morning, everyone. Thanks for coming and staying around this long. So my name's Blain Jones. I got my PhD from The Ohio State University, and now I am a life science product specialist at Ted Pella. Today I'm going to be talking about microwave methods for biological EM sample processing, specifically utilizing Ted Pella's Pelco BioWave Pro Plus. So also a special thanks to the talk organizers for inviting me to come to give this talk today. So starting with the basics of microwave energy, microwave wavelength at 2.45 gigahertz is about 4.8 inches in air. So what this results in is within a closed cavity, they constantly produce a standing wave pattern. So high and low energy density areas in a field which results into hot and cold spots. So typically in a household microwave, how these hot spots are utilized is by putting a plate of food on a rotating carousel, and then that passes the food through these hot spots, then heating or cooking the food. Though in the laboratory setting, we typically don't want to cook our precious samples, so we have to look at ways to get around that. So more of the basics here. So the magnetron, this is what produces the microwave energy. The waveguide directs it into the cabinet. The wave stirrer ensures the microwaves are dispersed within the cavity. And then there's the microwave energy itself. So microwave energy interacts with polar molecules, and it's thought to lower the activation energy required for a reaction to occur. So utilizing microwave energy directly, we can speed up reaction rates independent of temperature or heating. So this is what we call the microwave effect. So how microwaves interact with some different molecules on metals or plastics, it's either reflective or some of plastics are microwave transparent, so there is no heating that occurs. However, polar molecules such as water, solvents, resins, these readily absorb microwave energy, resulting in the heating of those materials. So for our laboratory setting, in order to utilize microwave energy for our experimentation and our sample preparation, we need to be able to control these variables of the microwave environment. So talking again about a household microwave, there is very little control at all, so that you have continuous fixed microwave energy. The energy is not uniform across the cavity. There are hot spots and cold spots. There is no temperature control at all, and the heating rate is high because that's the purpose. They want to cook food. However, in the BioWave, what we have is a continuous variable power level. The energy field is uniform across the chamber. There is active temperature control mechanisms, and the heating rate's been eliminated because we want to not cook our samples. So this is giving us more control over these variables. So how do we do this? So utilizing some patented technology that we have, the Cold Spot Pro, we're able to remove that standing wave pattern from inside the microwave cavity. So utilizing the polarity of water, we're able to absorb excess energy from the microwave cavity, effectively eliminating those hot spots to produce a uniform processing environment. So here's a diagram showing that. So on the left, we have a heat map of the inside of a typical household microwave. And then on the right, we have inside the BioWave with the cold spot. So you can see that those hot spots have been effectively removed, creating a uniform energy field. Just a moment. So what makes the BioWave different? Furthermore, in addition to the cold spot, we have variable microwave power output. So we have adjustable wattage control from 100 to 75 watts, controlled continuous microwave energy as opposed to pulse power as is typical on most other microwaves. So the importance of this control is it limits the exposure of a specimen to the minimum energy necessary for processing. It allows the microwave energy to be an active variable in the process, and it helps us produce consistent, reproducible results. So being designed to properly use microwave energy, the BioWave provides tools for the control of the environment in the internal chamber and at the specimen level. So some advantages specifically of utilizing microwave processing. You get rapid processing times and overall time savings by utilizing the microwave effect, which we addressed earlier. Also, you get typically superior processing results. This happens through better structure preservation, through faster fixation times, as well as increased diffusion rates. How that happens is there's a vibration of polar molecules at that 2.45 gigahertz. At high energy, this would normally result in the hydrogen bonds breaking, resulting in the release of heat, which is what we don't want. But at low energy, such as that utilized in the BioWave, the microwave energy imparts movement of the water molecules because they are some of the most absorbent molecules to microwave energy. We also get less cellular extraction and less background staining. Furthermore, we're able to control the sample environment for consistent reproducible results because each of these parameters and variables we're able to set and adjust as we need for our protocol. We're also able to reduce the reagent volumes required for processing and provide some solutions for more troublesome specimens. So with a single instrument, we're able to have the versatility to work for multiple different applications. And this is supported by experimental evidence and published results. So while everyone is here, electron microscopy, that is the most popular application for using the BioWave. So you can do complete EM processing from fixation all the way through resin polymerization and get results that match or even exceed the quality of traditional benchtop processing. And we have specific application kits. So for EM, we have an accessory kit that has everything you need to use right out of the box. And this is just a picture showing some of the various setups within the BioWave chamber using some of these different accessories. So different sample holders for your processing, vacuum chambers to aid in penetration into your sample, and our polymerization system. So microwave assisted tissue processing from electron microscopy is no different from conventional processing methods. The reagents used on the bench are typically used in the microwave, and the number of steps in conventional processing are usually converted directly over into microwave steps. So you don't change the protocol, just the timing of the protocol. And depending on the application, microwave processing can result in a ×4, ×10, or even 20 times faster processing times. So this little chart that you can see now. So on the left, we have benchtop processing typical times that it takes for normal EM. And on the right, we have BioWave. So you can see that you can take something that would normally take over 24 hours, you can accomplish in 2 hours with the BioWave. So from fixation all the way through having a block that's ready to section. So here I'm going to show some images comparing just to show results of that 2-hour processing time in the BioWave. So here on the right, we have some K9 nasal cilia. Here we have microwave assisted small bowel biopsy. And then here we have several rat samples, so cerebellum, heart, kidney, liver. So all types of different tissue types can be done in the BioWave. And as a bit of an aside here, there are additional application areas as well, not just for EM. So it can be used in immunolabeling with fluorescence or immunogold, different types of fixation or decalcification, different staining and paraffin tissue processing. So one instrument has a lot of versatility to it. Just also some of the features here real quickly. So full control over all the experimental variables and parameters, live runtime graphs to get an easily accessible view of the current protocol in real time. And the protocol selection screen allows both preloaded and custom protocols to be used. So the BioWave fits nicely into a core facility or a multi-user environment as well, because there's options for users for data manipulation. So each user can create a folder for their protocols and recorded data to keep on the BioWave directly, or keep it separate on a USB key and on a separate computer. So there's an app that can be used with it as well. So it facilitates the data transfer and review from a computer to the BioWave, as well as custom protocol creation and upload. So if interested in something like this, I would really encourage you to check out our website. We have lots of sample protocols there for many different applications and types of tissue, and using different reagents for EM as well as other applications as well. And they're all step-by-step, even pictures included to show how you use the different accessories for each step in the protocol, and showing the estimated times that you should use for each. Furthermore, we have a published material search page on our website. So currently it has 175 published works in here. For these are BioWave processing or methods where BioWave processing was utilized. So I'd encourage you to look in there to see if your type of tissue or your application has been done, because I'd almost guarantee that it probably has. One caveat here is that this is a little lacking behind current. So for works done since COVID or after, you probably need to do a literature search directly. But anything 3 years or older is likely to be on here. So why consider this technology? There's the versatility of the instrument. It can be adapted to each lab's workflow. There's an overall time savings for most procedures, up to 95% faster than traditional bench processing. So the efficiency and productivity of your lab will increase, and you will get equivalent or even improved image quality over traditional bench processing. And this technology has a proven track record of over 25 years. So it's been around a while. There's a lot of publications to back it up and prove the results. So if you have questions, I know we're running behind here on time, so please feel free to contact me via email. Here's my contact on the screen, just my name @tedpilla.com, and I'd be happy to answer any questions you have.